Section 6.2 continued. Now we're going to practice finding specific areas under the standard normal curve for given z-scores using tables and calculators. This particular video will concentrate on finding the values from a table. Look for a separate video on how to find these values using a calculator. Example 2. Sketch the area under the standard normal curve over the indicated intervals and find the specified area. As you're learning how to find the areas under a standard normal curve, I highly recommend drawing a picture every single time. And if the directions say to do that, make sure you actually sketch an area. It's very difficult to know which part of the curve you want versus what you don't want just by looking at a number and not having a picture. So every time you do these, draw a picture, draw a picture, draw a picture. Okay, let's look at A. To the right of z equal to 0. Now we've already had experience with this in a previous problem, but it doesn't hurt to take a look at it here to see how this value shows up on the table. So there's my picture, a bell-shaped curve, and there is 0 right there in the middle. And we want the area to the right of z equal to 0, so that's over here. All this area continuing into the curve. Now previously we said the entire area under the standard normal curve is equal to 1. And if I'm right in the middle, then the half to the right, or to the left, but in this case to the right, has to be 0.5. So we know the answer to this one. But let's just see how that shows up in our table. So if we take a look at our table here, and the way you read this table is you have these values here on the side, these your z-scores, but they only go to the 10th place, or the first value after the decimal, and then the numbers across the top take you to the 100th place after the decimal. Now for 0, it's just 0.0, and we have this value here, which we knew we were going to get, but we'll take a look at some other problems and see how to use these tables, looking at that first column and then going across the top row. Let's take a look at B. To the left of z equal to negative 0.47. So I draw my picture. There is 0 in the middle, and negative 0.47 is probably right there. And we want the area to the left. So all of this going into the tail. Again, before I get started looking at my table, I at least want to know an estimate of what should happen. Notice that negative 0.47 is not quite to 0, so I'm not quite to the halfway mark, which means my area has to be less than 0.5. It's not very small either, so somewhere in the range of 0.3 to 0.4 something is what we should get. So let's take a look at our table. Now this is a negative value, and I'm going to look on my negative chart. And first I look for negative 0.4. So that means I go down here on the side. Here's negative 0.4, but I need to go all the way over to get 0.47, which is here in this column. So we get a value of 0.8708, it looks like. I know this is... No, that's not... Oh, I think I'm looking up the wrong value. Now this table's pretty bad. 0.4 is way down here. And 0.47, 0.4, then 0.47 is here. So that should be 0.3192, which makes sense. Definitely less than half, but not teeny tiny either. So 0.3192 is the area under the curve to the left of negative 0.47. Take a look at C. To the left of z equal to 0.15. Again, we'll start with the picture. There is 0 and 0.15 about right there, and we want to go to the left again. So all of that in there. So again, before I go to my table, I at least want to know what I'm looking for. Well, 0.15 is a little bit to the right of 0, so I'm past that halfway mark, so my area has to be larger than 0.5. Let's take a look and see what we get. This is a positive value, so I'm going to look it up on my positive table. 2.1 is here, and I go over until I get that 5, so that's right here, and that value is 0.5596, looks like. The area here is 0.5596, which again made sense with our estimates since we knew it had to be a little bit over half. Okay, D. To the right of Z equal to negative 2.17. So here's my picture. There's 0 in the middle. Negative 2.17 is over here, and we want to go to the right. So all of that over there. Okay, so here's where things get a little different, and we need to be a little bit savvy with what we're doing on our tables. Our previous two areas in B and C were going to the left, which is exactly how the examples look in our tables. But this one is going to the right. Now if I try to look that up on the negative table, because 2.17 is a negative value, I wouldn't get the area I'm looking for because all of these values are less than 0.5, when clearly this is larger than 0.5. It's going to be a pretty big number. So think about how the shape of the standard normal curve is completely symmetric. The left side looks exactly the same as the right side. Well, this picture more closely resembles what's going on with the positive values. So I'm going to get the same area, it just happens to be on the flip side. So I'll look on the positive chart. I'm just going to look for positive 2.17, but it'll give me the exact same area as if I were looking for negative 2.17. So 2.1 is here, and I go all the way over to 0.7, and it looks like 0.9850. And here's another way we could also think of that. Now that 2.17, we might feel more comfortable looking it up on the negative table. So let's say I do that. But remember, this table is giving me values going to the left, and we wanted the values going to the right. But if I did look up negative 2.17, that would be here, 2.17. That's a value of 0.0150. Okay, so that's the left tail, but I really want the right. Well, remember our rules we learned about complements? That still applies here. So if I did 1 minus, because remember the total area is 1 minus 0.150, there's that 0.985 that we got previously. So I'll leave the decision up to you when you have one like this that doesn't quite match your table. You could either look up the opposite value, which will still give you the same area, or you could just look up the tail and subtract from 1. Now let's take a look at E. This time we have the word between. So I'm looking for the area from 0.32 up to 1.92. So I only want the area between those two values. Well, this one we have to do a little bit of arithmetic. First, I'm going to look up the area for just 1.92. Going into the left tail. So all of that, which is a pretty big area. And if I look that up on my positive table, here's 1.9, and I go over to the 2, that looks like 0.9726. Okay, so this is 0.9726 for that large area. Then I'm going to look up the area for 0.32 by itself. So there's 0.32, and that's going off into the left tail, and I'll also look this up on the positive table. So 0.32, there's 0.3, and go over to 0.2, so 0.6255. And to get that area that's just in between, what I want to do with these two is subtract. So that gives us 0.3471. So the area just between 0.32 and 1.92 is 0.3471. And finally, let's look at F. So I want the area between negative 2.18 and 1.34. Just between those two. So again, I'm going to have to do a little bit of subtraction to get this one. So I'll look at the area from 1.34 into the left tail. That's a positive value, so I'll look at my positive table. Here's 1.3, and I go all the way over to the 4. It looks like 0.9099. And subtract from that the area from negative 2.18 into the tail. Now that's a negative value, so I'll look on my negative chart. So 2.1, I go all the way over to 8, so that's 0.0146. So the difference between those two gives me the area in between, and that is 0.8953. Especially with areas between, be very careful that you find the areas first and then subtract. It does not work to subtract the numbers first and then find the area. So I can't say 1.92 minus 0.32 and then find the area. It won't work that way. So find the area for the largest value, meaning the value with the largest area, and then find the value for the, or find the area for the next value, and the difference between the two will be the area between the two. Recall that probabilities, when we work with those, are also between 0 and 1 inclusive, meaning a probability could be equal to 0 or it could be equal to 1. We can use associated areas under the standard normal curve with probability. So these areas that we're finding can also double as probabilities. So now that we're comfortable with finding the area under a curve, we're going to introduce our probability notation to do the same thing. So for example 4, find the indicated probabilities. In A, I have the probability that Z is less than 1.2. Again, we want to start with a picture, just like we did before. And 1.2, I'll put about right here. Now this time, we have to decide, based on the inequality, whether we want the area to the left or to the right. And in this case, because Z is representing all the values less than 1.2, that means we're going to go off into the left tail. So I'm looking at my picture, I'm beyond that 0, that halfway mark, so I know my area has to be bigger than 0.5. And because 1.2 is positive and I'm going off into the left, I'll look on my positive chart. So here's 1.2, and the hundredths place, the second place after the decimal, is still just a 0, so I can just stay here on this first value, which looks like 0.8849. So the area or the probability that z is less than 1.2 is 0.8849. Okay, let's try B. I want the probability that z is greater than negative 1.5. So again, I start with a picture. There's 0, and negative 1.5 is about right there. And we want z greater than negative 1.5. So that means I'm going to go off to the right this time. Well, remember, our table gives us values going to the left. So there's two ways I could do this. I could either look up 1.5 on the negative table and subtract it from 1, or I can just look up positive 1.5 since the standard normal curve is symmetric. Now I'm going to choose to do that because then that eliminates an extra step of having to subtract, but it's not a right or wrong. You choose what makes more sense to you and certainly go with that method. But if I look on the positive table, see my picture looks more close to what's going on here. And I'm going to look up 1.5. I'll go down here to 1.5, and again my hundredths place is a 0, so I just stay right here on this first value. That looks like 0.9332. So the probability that a random variable z is greater than negative 1.5 is 0.9332. And finally, with C, we have P of negative 0.73 less than z less than 3.12. So what does that mean? Well, when you have a variable sandwiched between two inequalities like that, this is when we use between, just as we saw in the previous problem. So to draw my picture, I have negative 0.73 on this side and 3.12 here, and I want the area in between those two. So just like we did before, we're going to have to do a little bit of subtracting. So the number that's going to have the larger area will be 3.12. So I'll find that one first. And then subtract from it negative 0.73. Okay, so for 3.12, we'll go to our positive table. And 3.1 is here, and I go over to 2, so 3.12, it looks like we have 0.9991, which makes sense. We're so far over into the tail. And then negative 0.73, and we'll look that up on our negative chart. So here's 0.7, and I go over to 0.3. Oh, nope, I didn't go low enough. Here's negative 0.7. And over to 0.3. So it looks like 0.2327. So the area between those two would be the difference, which is 0.7664.